I'm a gummy bear. Yes, I'm a gummy bear. Oh, I'm a yummy, tummy, funny, lucky gummy bear. I'm a jelly bear, 'cause I'm a gummy bear. Oh, I'm a moving, grooving, jamming, singing gummy bear.
Hello guys and welcome to another tutorial. In this case we will be showing how to make a really cool and great Vellum simulation of Gummyverse. You will be learning how to emit and how to colorize great Gummyverse. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. Okay guys, so here is how the scene begins with this nice bear, gummy bear, which I downloaded. So the first thing we got to do is because we're going to be bringing this to Solaris, is to set this as the render USD purpose. This basically sets so that you can change between render and proxy versions. You will see this in a moment how it works. I'm deleting everything that I don't need. I only need the normals as for now and the USD purpose. Remember, this has to be on primitive and it is a string. I will be then recalculating the normals because I realized that I had to change them. And the main idea is to create 3 sets of teddy bears. One big one, a medium one, and a small one. As you can see, this will be the big one in real scale. This is centered. This is the medium one, as you can see, and the small one. How is this done? Well, basically with a transform on 0.01 because I want to have... This is not real scale. I mean, this guy is like 4 meters tall, but I don't really care. Then I set the name. This is the name it will be having in Solaris. Then match sizing this and setting the rest position. Just this. I'm creating a big one. As you can see, it has the name and a box which represents the guy. It's just a box and an actual copy of everything without the position. This will become in handy later on. The same for the medium and the same for the small. I'm just changing the numbers to better suit my needs. And then I'm changing the names. The next step is very crucial, is how we are going to be setting the vellum. So it's to begin with, it's a remesh. Each remesh, as you can see, the smaller it is, the less detail it's going to have. This might be overly simple, so you can add more detail. It's going to work. In fact, it's going to probably have a better simulation. I just, for the sake of it, wanted to show you how it looks on a constant size of triangles. You can always link this together. Then a TED conform. The TED conform, I didn't change anything. I just added surface triangles. This is just a group, so I can then distinguish between both of them. We're not going to be using precisely this one, but it's always nice to have a purpose. In this case, it should be the USD purpose. USD purpose. This also comes in handy because we can potentially use this geometry as a proxy geometry in the viewport in Solaris. Then the same thing, the rest position, just because you never know, it can come in handy. And this is the big proxy. And then I'm just doing a text stretch with this stiffness, with a static topology, so it calculates a little bit faster. I just made it over the whole geometry. Remember that if you were to use the TED conform, it will just create like an inside geometry. So you can squish it basically. I didn't change anything. All the settings are exactly the same. And I'm separating the geobig with the combig and so on and so forth. And this is how you set up all the Gummyverse. To continue, we want to say where we're going to be emitting the Gummyverse and how. So let's import the box which represents, and you will see why. Let's import the box of medium, the mid one and small one, and pack them. We'll have these 3 boxes which represent the Gummyverse. All of these will be the variant equals to the number of points. Remember that when you pack, you will have a point in the center of this is just a point. As you can see, I could just select this as a point, and you will see that over there is a point. So then we want to create a sphere. This is where I want my gummy bears to spawn with an ISO offset, just so I can have some density. I'm scattering points all the way where I want. I'm adding some orient, where you can see this is the orient attribute. It's just an orient with 4 dimensions and direction on orientation. I didn't change anything else. This is how the boxes are going to be laying. And ID is equal to the ID to the PTNAM, and the ID real is equal to the ID. This will become also handy because usually you don't want to mess with the ID inside Vellum. So it's better to just have a secondary name for it. This is a node I have. It just create variant numbers, as you can see. It's just a randomize. As you can see, it's just a randomize with a global scale and a cast, which basically uses the same value to change it to an integer of 32 bits. And I'm using the seed, which is the one we got it here. Yes, here. This is the seed I'm using. As you can see, I'm using this ID real. I could also use the ID, but I decided to use ID real. And this will output different variants per point. If we were to go here to variant and do this, turn this on, you can see we have very few points which are, there we go, very few points which are violet, very few which are green, and a lot of, in this case, the other one, which are the small ones. What I try to do here is to have a lot of variance 0, no, very few variance 0, which is the big one, some variance 1, and a lot of variance 2, which are the small ones. So when we copy 2 points and set this to variant, we will have a lot of big boxes, small boxes, very few big ones, and an average type of mediums. But as you can see, all of these boxes are interconnecting within each other, and that's wrong, because in Vellum you will have one gummy bear inside another one. So we need to fix it. So I'm going to override the P scale with this value, and I'm going to go inside this Vellum Solver, RBD solver, and use this function. Copy and paste this function. What it basically do is adds a little bit of size until it reaches the P scale of 1. So this comes in extremely handy if you merge it with no gravity, a lot of drag, and a lot of spin. Nothing else. I didn't know why I did a ground plane, but look at this. You cannot see anything, but there's stuff here. It will just increase, and everything will just not collide. It will automatically push to where it needs to push, and we will then extract the orient and the pivot, because look at this. If we don't do that, everything is like wrong. I'm going to show you right here. As you can see, it was before and this is after. Everything's pushed nicely. If we don't do that, everything's wrong. So we need to do this. I'm just extracting the intrinsic transformation and plugging it into a matrix and doing a quaternion out of this to create the orients. And the pivot is just grabbing the pivot. Just copy and paste this code and it will work, and save it because you will use this many times in the future for sure. I'm adding this to remove the points and setting the P scale back again to 1. Otherwise, it's just not going to work. And setting this frame to, well, a frame that I know everything is correct. Then I'm clipping my points, as you can see, something like that. And then I'm just changing this clip. As you can see, I'm with Ctrl Shift Alt and drag, you reference it. What I'm doing is just on this one adding a -4, so it will be like this type of movement. Then I'm saying that the frame start is equal to -1, but I truly want to know which guys are activated. So what I do is the following. I grab the input 1 on solver and I transfer the frame start from the previous frame. Then if the frame start is equal to -1, set the frame start to the frame which is currently right now. So you will see that all the frames will start updating. And we will double check to see, hey, is the frame start equals to the frame? Because sometimes you will have like two different frame numbers in one singular frame. So you will just distinguish between both of them, and you will only be getting the frames which are required to emit. So this is how the gummy bears are going to be emitting in the simulation. Then the frame start is equals to the frame, because we always know that it is the same. So for example, in here, which I don't know why I do, this is unnecessary. I'm just keeping this just in case, but it is truly unnecessary. And I'm dividing the points between the variant 0, the variant 1, and the variant 2, which is this one, in order to distinguish between these three gummy bears, because we will be instancing the points. Developing into the points. So let's say this like so. And you will see once I press play, all the boxes will be emitting like so. It does have a little force to it, and they will just fall down. That's how I'm emitting. You can add any type of force you want anywhere here, like in the point. So for example, if I were to add, let's say, this velocity, like v add v is equals to, I don't know, this value, it will just push everything to the left side. So just so you know that you can create your emitters and do whatever you want with emitters, with velocities. In this case, most of the forces are being applied inside the solver. So how is this being done? So we have the points, we have the geometry. Let's combine this. So right click, you need to open this. So if we were to get a Vellum Solver, you right click and you allow editing of contents. Once you allow the editing of contents, you dive in again, and you go firstly to the sources. You will be creating or grabbing the subpath for the subpath, like this one. The same one, the geometry is going to be for the target, and the constraints, you will be grabbing the constraints, which is basically just these two guys. Also, you will be grabbing the same, if this is the big one, you will be also grabbing the big points, because we want to emit from the big points. This is $ROS because this is called big. Everything is called the same. So if we change the name, we will be changing the output. Then I want to have all these attributes to the instance so I can continue using them. And we will do the same for the medium and the small. It is all the same. We will all be on instance points. That's done. That's all there's need to be done here. On forces, we're going to be adding a secondary rest. This is important. So if the frame start is equals to the frame, the rest position 2 is equals to the position. Basically, where this starts, this is where the rest position number 2 is. Then, if the frame start is equals to the actual frame right now, let's add this force. So only for one single frame, let's add a lot of force so it can spin and do whatever we want. Nothing else. Everything else is just the simulation doing its job. Now, the post process, we will be doing one and the other one. So let's grab the raw simulation. And I really want to go up to a frame where all the teddy bears are already emitted. So in this frame, everything has been emitted already. Then this is the current frame. What we want to do is to the whole frame where I have everything and nothing else is emitted. I just want to delete everything which is not on the current frame. You would think, why are you doing this? This is in order so I can have a static transition on my bears. This is very important to have. This is super necessary. So let's go to the first one. This is going to be on the big ones. So to begin with, all of these guys come in with the inside geometry. So let's remove that inside geometry. We don't want it. We only want the exterior. Now, I only want the variant 0, which are the big ones. Let's create a connectivity so I can distinguish between all of these guys, as you can see. and we will be using this later on. Let's do a time shift again, just in case. Yeah, because basically we don't want this to be updating each frame. We already know what we have, and we know that on frame 1018 this is already all emitted. So which is the biggest class? I want to have like on this is going to go to detail. I want to know how many gummy bears we have. We have 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's 9 because it goes from 0 to 9. And I want to reset the gummy bears to its original position. I have all my gummy bears set to extract rest because remember we saved the rest position over here. Well, we are restarting the geometry where it belongs, all of the 8 ones. Over here, we are just promoting primitive class to point because we will be using this one to pair the attribute copy probably. So let's grab the big one. Let's reduce the geometry. This is going to be the proxy we will be using at the end of the day in Solaris. This will be the low, this will be the high. They use the purpose of this one is proxy. And this name is going to change to /proxy. You can see the original name, the addition. Now let's merge both. And we have 2 geometries. The proxy overlaying with the other one. Let's copy enough times so it's equals to the max class plus 1 because it goes from 0 to 8. We want to go from 1 to 9. So we're going to create 9 copies. Now we have 9 teddy bears here, which we can, if I were to show you, because we have the class v.x, it's equals to is plus equals to I class. If we need to promote this, right? There we go. See, you have all the teddy bears right now. There we go. So all the teddy bears depend on this value over here, which is the maximum. Just so it makes clear. So I want the ID to equals to the PT number, right? So we can see that the ID on all the points are going to be different. This is very important for interpolation. You want to have a static point number, so you can have a static ID number. That's why we have all of the assets already on the first frame. Even though I am emitting, this is important to like reverse engineer this. We're going to be transferring the ID real. The ID real, remember guys, it was like the number of the idea of the bear. Each bear has its own ID real, and then we're going to be grabbing this null, which is the positions over here. We're going to be promoting the class just to change from primitive to point, because remember you had the 9 bears, and we will be removing if there is no class. For example, let's go to this frame. We only have 1 bear. In this case, we only need to have 1 bear. If we go over here, we have, I don't know, 4 bears. This will make it so that we have 4 bears. In order to see this, again, let's create the same value so you can understand what's going on. VRP plus equals to ID real. Do we have ID real? Oh, there we go. Yeah, okay, these guys are way over there. It's normal because we have so many small ones that should be there. Let's try to do class then instead. There we go. So, just so we can see this better, I will be having more bears each frame we go past up to this frame where I know that, okay, this one is just up to frame 1018, which is this one. After that one, I see this is very slow. After that frame, I don't need to calculate anymore. I already know that I have the maximum amount of big bears. Once I have everything here, we have the bears, which has the high res and the proxy. We have the simulation geometry. We have also the raw simulation with all the variants. We have everything. We can now then, with the ID real, if it exists, because if it doesn't exist, it doesn't matter. We can move the bears around. As you can see, they will be emitting. And something which is nice, we do have an ID, which is non-changeable. It doesn't flicker, it doesn't do anything. So the trail, we can use the ID, match by attribute, to create velocity, which is super cool. And this is how you create the big bears. The only difference between the other ones is this one, that on the ID, I'm adding a previous, which I'm adding, I'm creating the same ID, but I'm adding the previous ID number. So why? I don't know if it really makes a difference in this case, but I think it does. When you make everything again, we will have all of the bears, all of them, with their own ID value. They will be all be emitted from frame 1 and they won't flicker and it will just work. That's what we want. We want this to just work. It is always convenient to have the trails before this one. And this is quite optimal in speed. I used to have another one which just went way slower. You can see over here the performance, how fast this is without looking at the viewport. We're simulating at the same time, remember this. So let's just go from here. Let's do one frame. Let's start moving. This is how fast this is. It's barely noticeable. Oh, so let's do this one. See, you barely notice anything of delay. It's most of the things are over here into the Vellum Solver. Oh, I was not clicking it, I think. Let's try again. My bad. Let's do it again. So this is the speed. As you can see, the most tedious one is the merge, which, yeah, I mean, it is a little bit complex. What you could potentially do is just to ingest this separately in Solaris, but I just didn't find this to be overly problematic, to be fair. That's the only optimization I would do to this setup, and you will be saving some time, but it wasn't worth it. I don't know. I mean, yeah, you can make it faster, but it's easier this way to prove the concept. And as you can see beforehand, we also have these ones which have taken a bit of time, but regardless of that, everything is just working fine. And that's it for this step. Everything else is just adding to Solaris. So in Solaris, the only thing we got to do right now is to grab the teddy bears. Remember, this will be quite slow at first until you cache it out. So we got up the out high, which is the last node from before. And we set the import path prefix to this because I want this to be super organized. And the layer say path to whatever you want. I decided to use, where I'm saying the heap, to use the bears version 1, bears version 1 USD. Then I'm saving this to disk. I decided to use flatten all layers. And once you have all cached, it's just super fast. It will be a little bit slow because I'm recording, but that's about it. Everything else is extremely fast for the amount of geometry you have. Plus, you can see that you can go to preview and you will see the proxy version, which we decided to use. That's why USD purpose is very nice, because now you can pre-visualize this extremely fast. Great. First step. This is rendered with Arnold. So what I decided to do is to add 2 subdivisions. Let's go to Arnold. There we have all the bears. This is saved. It has motion blur. If we go like this, we will see the proxy on the outside and the render on the inside. I'm adding a background. It's just a ground plane set to BG background with a lot of scale. Nothing else. That's it. I'm going to set this to 0 for the meantime, so it's a little bit faster. On materials, I'm creating the bear and the ground materials, and I'm adding them with a light dome. So what's going on here? The material library, it is the only one we need to check because the ground is just, well, roughness, nothing else. Is the bear one. What's going on here? So I'm going to set up something so we can look dev this one a little bit faster. Let's go from there. So this is the setup I'm using right now. This is for the look dev. Let's work around this. So what I'm doing is just to setting the verse to everything is called verse and a sphere, because I used to have a sphere before. But let's see how this was done. So firstly, what I'm doing is to grabbing the ID real. As you can see, some of them are 0, some of them are over 1. I'm randomizing the output from all the ID reals. As something that I wanted to show you, look at this. This is a strange bug, I think. If I were to set this to points, it just writes. Set this to primitives if you're handling with geometry that's going to be subdivided and it is on integers. So we create a random random between each of these, and we run this value with a gradient. As you can see, I'm using these colors. These two looks the same, but one of them is orange and the other one is red. I'm color correcting this a tad with less saturation and setting another one with a little bit more saturation for the subsurface radius. This is going to go to the subsurface color and subsurface radius. As for this is for the this is meant for the roughness, cold roughness and specular roughness. This is created with a texture set to triplanar with these values, set to pref because we're using the rest position, guys. Do you remember? And then on the RAM float, we're making this more contrast. The same for this one. These are just two different textures. This is set to job, so when I send this to the render farm, it just works. This is set with file set. What is it set? Set project over here. Then I'm mixing both things together, so we can have a mixture. This is going to be like the roughness map it's going to have, but it's also going to work with the bump in order to create a bump map for the normals. What it has to do with the specular, I decided to use the specular 1.3 and a surface of random walk of subsurface 1 and scale to 100 and anisotropy to negative 0.21, so it can absorb a little bit of the light. Well, we have all these guys. If we combine everything, we will have this. I set everything to the GPU. These are our bears. If we change the subsurface scale to 1, it's going to be more. It's going to be subsurface. It's going to be strange. So I want it to have like it being so subsurfacely that it's like translucent. That's the whole material, to be fair. So that's all the things that are going to be applied to this verse, which are falling down with motion blur. What else? Oh, one thing. I'm grabbing a camera. This is the camera. And I'm adding Arnold render settings with some AOBs. It's just a set and not adding anything else. I think it just stopped working, the render, but it doesn't matter. And I'm rendering from frame 50 onwards on both cases. Well, this should have been saved, but it's from frame 50. And you are going to be having another node. This for me to send to the render farm, but it's just USD render wrap. And you plug this in a specific frame, and you do 50, and in this case, Arnold. That's all there is. There's nothing else. And in this case, the only thing that I did, this is just to grab the lights, and I wanted to create like a slow motion effect for the second shot, just to check. So what I did, and this is going to be a little bit slow, but this is animated. I grabbed the verse or the proxy and the render, and I just unpack this into polygons. We have everything here, and with a better time. This is why the ID comes in extremely handy. I'm just setting a slow motion version. It will be slow to pre-visualize this. I don't really need to do it. And I'm also setting the multiplier of the velocity to this scale. because I know it's going to be constant, so I just do the same. With all this, I create another camera and I render this new camera, and that's all there is. There's nothing else for the effects section. And we are here into the compositing stage. So this is pretty simple, to be honest. Pretty simple. Firstly, there is an exponential glow, which I will leave the link down below. I will show you how is it used. It's actually super simple. But overall, it's pretty much vanilla. So we have this render that came out of Solaris. What I did is to plug the RGBA into the RGBA. So we have the image. And then I added a set defocus. Basically, I can choose where this is getting focused based on the set.set, which is what we output from the render node. Then I merge this with a background. It's just a constant. And then there is a exponential glow. Super simple. You can mess around with the settings and how many exponents you want it to work. You can blur it. You can do whatever. A lot of things to do, right? So, and you can add some tolerance. So it's not always, but on just the right parts. And you multiply it with something and then merge it. Basically, the multiply acts as a mix, right? So instead of going here, you just go here. Look at this. I always set the bounding box to B, which is this one. So instead of having this huge overlay, I just flip it. This is the same. I'm adding a little bit of color corrections, just a little bit of contrast, then a little bit of gain to pop it up a little bit. Then balance distortion. I decided that this is nice. And then I divided everything into 3 channels, red, green, and blue. On the blue, look at this. I'm adding a little more of fish lens with this number. And what I'm doing over here is that I'm just click with a control and dragging it over here. I'm not going to do it because I already did. And then with right click and edit expression, I added this negative value here. So it's the opposite. So one is going inwards and one is going outside. The red, I like it to be on the outside with a little bit of blur, as you can see. So when you go into the edge on the right, it's always like orange-like. The blue adds as diffuse. Look at this, super cool. Just 2 pixels is nice. Then a slight transformation. So it's fine. It works in overall. Remember to work this. Yeah, no, I didn't use anything else. Then just a simple transform. And then a crop to crop it. And a grade with a mask, which is radial. We can see it over here. After that, just some noise. I should have used the noise beforehand, but I didn't because I just didn't really care. And some output transform on output sRGB because this whole project, if we press the letter S, it is on ACES because the export is in ACES. And that's about it. There is nothing else. I hope that you like the video. Please leave a like, comment, and subscribe. Stay tuned.
Oh, I'm a gummy bear. Yes, I'm a gummy bear. Oh, I'm a yummy, tummy, funny, lucky gummy bear. I'm a jelly bear.